Logarithmic functions. In this module, you will learn about logarithmic functions. Recall that along a line y is equal to x if the graph of a function is a reflection of the other function, then that function is called the inverse of the other. Also, if there is a function f so that f of x equals b raised to the power x, where b is any positive value greater than 1, then the function is an exponential function. Let's plot a graph of an exponential function y equal to 2 raised to the power x. Now what if we need to plot a graph of the function x equals 2 raised to the power y? Here you can see that base 2 is the same in both the functions. Only x and y have interchanged their positions. So, to plot a graph of the function x equals 2 raised to the power y, flip the order of the ordered pairs on the first graph and plot them. For example, 3, 8 will become 8, 3. Similarly, 2, 4 will become 4, 2, and so on. Now joining these points, we get the graph of the function x equals 2 raised to the power y. Now, if we draw a line y equal to x, we can see that the two graphs are the mirror images of each other, reflected along this line. So, the function x equals 2 raised to the power y is an inverse of the function y equals 2 raised to the power x. So we can generalize that the inverse of y equal to a raised to the power x is x equal to a raised to the power y. This lets us introduce a new class of functions called logarithmic functions. If a is any real number greater than 1, so that a raised to the power y equals x, we can say that the logarithm of x to base a is y, and it is denoted as shown here. This function is known as a logarithmic function. Here we have x equals 2 raised to the power y, which can be represented as the logarithm of x to base 2 equals y. Now we can say that the inverse of an exponential function is a logarithmic function. When the base of a logarithm is 10, it is called a common logarithm. And when the base of a logarithm is e, it is called a natural logarithm. We denote a natural logarithm by a symbol ln. We will denote a natural logarithm of x simply as log x. Look at the graphs of these logarithmic functions with base 2, e, and 10. Looking at these graphs, we can generalize some features of logarithmic functions with base greater than 1. Since all the functions are defined for only positive and real values of x, the domain of a logarithmic function is the set of all positive real numbers. Since the output y is any real value in these functions, the range of the logarithmic function is the set of all real numbers. The point 0, 1 lies on the graph of every logarithmic function. As we move from left to right, all the graphs are rising. Thus, a logarithmic function is always increasing. You can see that for x very near to 0, the graph of a logarithmic function approaches the y-axis in the fourth quadrant. In this module you have learned, if a is any real number greater than 1, so that a raised to the power y equals x, we can say that the logarithm of x to base a is y. Such a function is known as a logarithmic function. Some features of logarithmic functions are: the domain of a logarithmic function is a set of all positive real numbers. The range of a logarithmic function is a set of all real numbers. The point 0, 1 lies on the graph of every logarithmic function. A logarithmic function is always increasing. As x approaches 0, the graph of a logarithmic function approaches the y-axis in the fourth quadrant. An exponential function and its inverse, which is a logarithmic function, are the mirror images of each other reflected in the line y equals x.